Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat. So then we'll ready to go. Anyways, the agenda behind the series of the engineering mathematics which we have been running so far must be very clear to all of us. We are learning the basic concept of the engineering mathematics from where we sketch. What are the different topics which we have covered since 14th number of lecture? Let me recall what are the different topics which we have covered so far. At very beginning, the first topic was completely based on the logarithmic function. There we were discussing about the different kinds of the logarithmic function, what used to be the base of the logarithmic function, what are the different feasibilities with the base. The base can't be negative, base can't be 1, base can't be 0. There are several different portions which we were studied under the logarithmic function, and at the same time we also drew the logarithmic function over the xy plane, and we got to know the logarithmic function is defined only and only for the positive value of x. That part we have already seen. Agreed what I am saying? And similarly, in next 2 to 3 videos we were discussing about the linear equation which was drawn over the xy plane. We talked about its standard formula in terms of y is equals to mx plus c, y minus of y1 divided by y2 minus of y1 is equals to of x minus of x1 divided by x2 minus of x1. And even we took around 5 to 6 important numericals, and the numericals from where the problem has been repeatedly been asked has been m1 into m2 is equals to of minus 1. That has been m1 has been the slope of the straight line number 1 and m2 has been the slope of the straight line number 2, and if they have been orthogonal on each other, definitely their multiplication has to be equals to of minus 1. That we have seen earlier. And in the same sequence we also talked about the trigonometric function. In the same sequence we discussed about the trigonometric function. There I saw how the cos of x, sin of x, tan of x, cot of x, sec of x, cosec of x would look like over the xy plane, and yes, we should have a little bit idea graphically how they look like. Once we were done with this, we were discussing about this circle, the standard circle which has been placed over the xy plane. We talked about parabola, and in last video precisely I was discussing about the limits. And more or less I was discussing about the theoretical understanding of the limit and the important formulas which we use within the concepts of the limit. Let me recall what are the different concepts which we have studied in the last class, because my today's video would also be more or less based on the concept of limits only. See what are the different concepts which we have studied earlier. In case of limit, we saw you would be having a function which had only one independent variable. What you do? You try to approach to its test point. Let's take the test point has been a from the left hand limit as well as right hand limit. If from the left hand limit as well as right hand limit you reaches to the same worth, in that case you assume the limit do exist of this function around x is equals to of a, and that would be your answer. Which you have seen earlier. No, it's just a sort of summarization what we have studied earlier. In the same sequence, what you're going to do over here, if again you intended to get the limit of a certain function f of x, and for the time being you have come into the situation where right hand limit as well as left hand limit has not been same. Keep in mind, in that case the limit does not exist. That means you would not be able to get the answer at all. Limit does not exist. Till this point, each and everything must be clear to all of us, which you have seen earlier. No, I don't feel that any of us would have any sort of doubt over here. That has been the second one. Similarly, in the same sequence, in third situation, mathematically we try to get how we can get the left hand limit, left hand value of f of x, and similarly right hand value of f of x. So what is happening over here? We are approaching at x is equals to a from the left hand side. So obviously you would be stopping yourself at a minus itself. And similarly, when you are slowly moving towards right hand side, and if you are approaching towards a, obviously you would stop yourself at a plus itself. So what I am saying, the limit do exist at x is equals to a for the function f of x, when the left hand limit, what would be the worth of the left hand limit? It would be simply equals to of worth of the function just before a, and that would be f of a minus itself. F of a minus has to be very same as f of a plus. How mathematically is being written? It has been written as limit of f of what it is? It has been a minus of h, where the h tends to 0, and as the h is tending towards 0, obviously end of the day you would be reaching just before a, which had been f of a minus. Similarly, what happens towards right hand side? At right hand side it used to be f of a plus of h, f of a plus of h. During the discussion of the limit, it has already been noticed, until and unless there is no sudden jump at the test point, the limit would exist. Yes, the failure of the limit test takes place, failure of the limit test takes place when there is sudden or abrupt change in its magnitude, sudden change. So the point at which there is a sudden change in the magnitude of f of x, there the failure of the limit would take place. Till this point, probably each and everything must be clear to all of us. Nobody should have any sort of doubt. In the same sequence, what I am going to do, let me take around 6 to 7 number of problem, and we'll try to figure it out. What are the different functions where the limit would exist, and what are the different functions for which the limit does not exist. What I am going to do over here, the first problem had been like limit of this had been the first question of the day. The limit of x tends to 0 of f of x, where the f of x is being defined as mod of x divided by of x when the x is not equal to 0. And similarly, it has been defined as precisely 1 when the value of x has been precisely 0. That means I need to get the limit of the function f of x, where the f of x is being defined as a mod of x divided by of x when the x is not equal to 0 and had been the magnitude precisely as 1 when x was exactly equals to 1. So there are several methods through which this problem could have been spaced out. I am going to use the 2 to 3 different methodology. Whatever the methodology you find easier, you can follow in GATE examination. The first most method would be, see what is happening over here. The first method, and each method have got its own advantages as well as own drawbacks. Let me start with the first method 1. As the limit test has to be conducted at x is equal to 0, that means you nothing to do with the worth of the function at x is equal to 0. What I am saying, you had to nothing to do with the function of the x at x is equal to 0, which had been 1, because you would be restricting yourself at a minus as well as a plus, so nothing to do with 1. So keep aside. Let me recall how the function would look like. So here one thing had been quite sure. When the x had been negative, mod of x would be referred as a minus of x divided by of x would become minus 1. And similarly, once the x is greater than 0, mod of x would be referred as plus of x, and the plus of x divided by of x would be simply equals to 1. So one thing is quite sure. Simply just focus over the worth of the function before test point, that had been 0 minus, and similarly after test point, which had been 0 plus. And as far as the f of x, which had been written as mod of x divided by of x, which had been a signum function, is concerned, has been defined as a minus of 1 for x lesser than 0 and had been defined as a plus 1 for x greater than 0, and the worth had been precisely 1 at x is equal to 0. So obviously you had to check the worth of the function just before 0 and just after 0. Just before 0, the worth of the function would be asked from here, and that had been minus of 1, and here it had been plus of 1. Obviously left hand limit and right hand limit had not been same. What does that mean of it? That means there had been a sudden change. In a magnitude. Put together, the limit would not exist at x is equal to 0. That has been the first method. The limit would not exist. That could have been the first method. What could have been the second method? In the second method, I can take the reference of the graphical approach. For that, what I am going to do over here, let me take a xy plane. Here goes the vertical axis y, here goes the horizontal axis x, here goes the x-axis, here goes the y-axis. As far as the mod of x divided by of x is concerned, it has been defined only for x not equals to 0. That means it would be valid everywhere except y-axis, because at y-axis the value of x used to be 0. What would be the nature of mod of x divided by of x? It would be minus of 1 for negative value of x, and similarly it would be plus of 1 for the positive value of x. So the output is going to be something like this. It becomes minus of 1 for or negative value of x, and it becomes plus of 1 for all positive value of x. Till this point, each and everything must be clear to all of us. And obviously, the magnitude has not been defined at x is equals to 0 or at y-axis. But the magnitude has been defined precisely at 1 at x is equals to 0. So the magnitude would be somewhere here, and here it would be a hole. Here it would be a hole. Graphically, once you are done with the given function, obviously you yourself would be able to understand where the test point has been. The test point had been at x is equals to 0. That has been your test point. The x is equals to a 0 had been your test point. And once you conduct the test at x is equals to 0, you yourself would be able to understand just before x that used to be 0 minus, and just after the x which used to be 0 plus. May I know what is the worth of the function? Here worth of the function had been minus of 1. You can say f of 0 minus had been minus of 1, and similarly at f is equals to of 0 plus, the worth had been plus of 1. So as far as the existence of the limit is concerned, where the limit has to be calculated, as per the problem the limit has to be conducted, or the limit test has to be performed at x is equals to 0. The left hand value as well as right hand value had not been same. That means the limit do not exist, or there had been a abrupt change in the magnitude. What I am saying over here, again the second method has been used over here. Which color should I be using? Okay, let me use this color. And here what I am saying, sir, f of 0 minus as well as f of 0 plus graphically had not been same. It had been minus of 1, it had been plus of 1. Left hand limit as well as right hand limit has not been same. Limit does not exist. And the student who have been attending my class from the first or the beginning onwards, definitely without touching the pen and copy, they could have got the appropriate most answer for this given problem. Yes. Till this point, each and everything must be clear to all of us. In the same sequence, let me take the next question. Here goes the next question. Deliberately, I am going to design a sort of hodgepodge problem. The f of x has been in two parts. In first part, it has been a straight line. In second part, it had been a parabolic structure. For the better understanding, what I am going to do over here, the parabolic structure, let's take it had been upper facing parabola. Y is equals to of x square, and it has been defined only for all value of x lesser than equals to of 1. And similarly, the remaining part of the function has been defined as x for x greater than 1. I need to perform the limit test of f of x at change point x is equals to of 1. Or I can say I need to find the limit with x is tending towards 1 for function f of x. Tell me what would be the precise most answer. There could be the two different possibilities. The limit do not exist. If the limit does not exist, obviously you won't be getting any answer. You could have the second possibility where the limit do exist, and once the limit do exist, obviously you would be getting a precise most answer. Tell me what would be the best most answer. See, what would be my approach? As we have been using the two different methodologies, two different approach, obviously we are going to use the two different approach. May I know what? The first is the simplest mathematical form. What we are going to do over here, we are going to get the worth of the function at where the limit has to be conducted. Limit test has to be conducted at 1. So obviously, if I will be using the path which had been moving from the left hand side, and we are keep moving till my test point x is equals to a, so obviously you had to stop yourself before a, and that has been a minus, or which has been 1 minus. And similarly, if you do the same process from right hand side, you would stop yourself at 1 plus. Sir, can we find the limit of modular function? Obviously yes. Why not? Could you understand what I am saying? May I know what does it mean by the 1 minus and what does it mean by the 1 plus? Many of the students used to have little bit doubt over the 1 minus, 1 plus, or the notation of a minus or a plus. 1 minus, that means still this value is very near to 1 but towards the left hand side. You can say value as 0.999999. Nobody should think this as f of minus 1. Minus 1 is something very different than 1 minus. Similarly, what does that mean by the 1 plus? The magnitude or the worth of 1 plus is very near to 1, but it's just towards right hand side. You can say 1.00001. May I know f of 1 minus and as well as f of 1 plus. We had the two distinct nature of the function taking the reference of x is equals to 1. F of 1 minus, should it be asked the value from the x square or should it be asked the value from x? And similarly, f of 1 plus, should it be asking the value from x square or x? That is quite self-explanatory. This function would give you the proper worth of the f of x for all possible value of x including 1 and lesser than 1. Obviously, 1 minus had been lesser than 1 only. So what you are going to do over here, 1 minus would be squared. Now many of the students would think, sir, why you are writing 1 minus? You can write 1, no issue, because 1 minus and 1 does not make much sense as far as their magnitude is being concerned. They have been almost same. Similarly, 1 plus, it has been just 1 plus itself. And once you'll compare them together, obviously the worth had been 1 is equals to of 1. 1 is equals to of 1. What indicates? It indicates left hand limit had been very same as right hand limit. Left hand limit had been very same as right hand limit. The limit do exist. May I know what should be the worth of it? The worth had been plus of 1. The worth had been plus of 1. Let me use the second methodology. Obviously, it would be a graphical methodology. For that, we are going to have a xy plane. It had been a method 2. It had been a xy plane. Here goes the vertical axis. Here comes the horizontal axis. The horizontal axis has been marked as x-axis and the vertical axis has been marked as a y-axis. May I know the value of x at which the change point has been taken place? Obviously, it had been 1. Before and equals to of 1, the function of the worth had x square, and from there onward, it had been changed to x. So obviously, I would be taking a change point. For the better representation of the change point, let's take x is equals to a plus of 1, which would be a vertical line, which had been displaced from the y-axis with the 1 unit, So here goes, yes. First focus over x square, how the curve would be. Obviously, it would be upper facing parabola. So the curve would look something like this. It would be upper facing parabola. May I know at x is equals to 1, would it make a hole or would it make a dot? Obviously, it would make a dot because the function would have its value even at x is equals to precisely 1. So obviously, it is going to make its dot. Which curve it had been? It had been y is equals to of plus x square, which had been upper facing parabola. Similarly, if we'll be focusing over y is equals to of x, may I know how the curve would be? Obviously, the curve would be a straight line. Let me take a different color. The curve would be a straight line which would be crossing through the origin, and similarly, once you'll be feeding the value of x, even the value of y would become 1. So obviously, it is going to cross through this dot also. For the better understanding, what I'm going to do over here, let me rub this out. If we allow it to move towards left hand side, it would strike to 0. But one thing had been quite sure. At x is equals to of 1, no. What I am saying, at x is equals to of 1, if I take the reference of x square, the worth had been 1, and similarly, if I took the reference of y is equals to x, the worth had been 1. That means at point of change, the worth of coordinate, which includes abscissa as well as ordinate, had been very same. That means one thing had been quite sure. The function has the limit at x is equals to of 1. Could you understand what I am saying? So many of the students would have a little bit doubt, but once they are going to understand the concept using the mathematical approach as well as graphical approach, I don't feel that any sort of doubt would be left out. Till this point, each and everything must be clear to all of us. Yes. In the same sequence, what we are going to do over here, I am going to write the two problems over the blackboard, and I would expect that you guys would be able to give the propermost answer without touching pen as well as copy. Because this sort of problems are meant for getting the answer with the highest accuracy and the least amount of time. How many number of questions we have taken so far? So total 2 number of questions we have taken. So now it's turn to move into the third number of question. Let's take the function had been obviously f of x had been defined as, let's take, it has been x square plus of 1 for x lesser than equals to of 1, and it had been defined as x for x greater than of 1, x greater than of 1. I need to find the limit of the function. I need to find the limit of the function when the x is tending towards 1. X is tending towards 1. There could be the two different possibilities. The first possibility, the limit do not exist. Once we are done with the limit do not exist, obviously you won't be having its appropriate answer. The second, yes, the left hand limit as well as the right hand limit is very same, and once we are having that situation, definitely you would be getting the what appropriate answer. Tell me which category this problem would fall. How many number of students are concurrent? The 3 number of students are concurrent. At least I want one exact most answer. See what is happening over here. The test point had been 1, so obviously the analysis has to be made over the 1 minus as well as 1 plus. Once you will be doing the analysis over the 1 minus, which function you would be choosing for the analysis? Obviously x square plus of 1. There instead the x you would be feeding the value as 1, 1 to the power of 2, that would become 1 plus of 1, that would become 2. So one thing is quite sure, if you wanted to get the left hand limit of the function at x is equals to 1, that has been precisely 2. That has been precisely 2. Similarly, if you move forward, and now if you calculate the worth of the function at x is equals to 1 plus, obviously the responsible function would be x, and here if you will be feeding x is equals to 1, the worth is going to be simply equals to of 1. So would you take this much amount of time? No, nobody should take this much amount of time. We would just be focusing over the worth of the function at left hand side, that has been f of minus 1, and similarly at right hand limit, which had been f of 1 plus, May I know what would be the worth of f of 1 minus? Many of the students would have certain doubts, sir, whether we are dealing with the minus of 1. No, almost 1, but from the left hand side. From where the value has to be asked? Obviously the value has to be asked from here. It becomes 1 to the power of 2, that become 1, 1 plus of 1, that become 2, and here it had been 2. The left hand limit as well as the right hand limit had not been same. How much time it has been taken? Probably not more than 30 seconds. That had been method number 1. In the same sequence, let me move into the method number 2. The method number 2 would be a sort of graphical method. For that, I am going to take a xy plane. Here goes the vertical axis, here goes the horizontal axis. It becomes the horizontal axis, it becomes the vertical axis. As far as the upper facing parabola is concerned, y is equals to x square used to be upper facing parabola which crosses through the origin, but now it has got lifted by 1 in vertical side. So what would be the structure? The structure would be sort of this. So here goes, at x is equals to of 1, the worth of the function would be 2. So obviously here the coordinate would be 1, of 2, and that has been upper facing parabola y is equals to of x square plus of 1. Could you understand what I am saying? And similarly, if you will take the reference of y is equals to of x, obviously at x is equals to 1, may I know what would be the worth of x? Obviously that would be 1 itself, and y is equals to x had been a straight line, so it would be a straight line which would be crossing through the origin and would have the slope is equals to 1, and at x is equals to 1 the coordinate value would be 1, 1. So let me complete this out. The curve would be sort of this. When you allow it to flow backward, it would be in this direction. Yes. So as far as the magnitude of the function at x is equals to 1 is being concerned, it had been a sudden change in magnitude. Obviously, the y is equals to of x square plus of 1 was following the magnitude as 2 at x is equals to 1, whereas y is equals to x has been following the magnitude as 1 at x is equals to 1. There had been a sudden change, and if there is a sudden change, obviously the limit would not exist. And even we got the same value, no? F of 1 minus, just before than this, obviously the magnitude would be 2, and just after this, the magnitude has to be asked from the straight line. May I know what would be the value? The value would be very same as x. If you are feeding x is equals to 1, by default the value of y would also become 1. Yes, till this point each and everything must be clear to all of us. In the same sequence, let me go into the next question, and it would be effectively bit complex problem. Let's take it had been a question number 4. It had been the question number 4. Let's take the problem had been limit x tends to 1. Just try to understand what I am saying. Limit x tends to 1, 1 divided by of x minus 1 to the power of 2. X minus 1 to the power of 2. Tell me what would be the best most answer for this given problem. I know many of the students would have little bit doubt, sir, x is equals to of plus 1 had been the pole of this given function, and even the limit has to be assessed around x is equals to 1, so obviously the limit would not exist at x is equals to 1. May I know whether you are getting the same answer or your approach or your answer would be bit different? So whenever you deal with the problem related to the limit, you come across the two different situations where the limit do not exist, and secondly the limit do exist, and once the limit do exist, obviously you would be getting its precise most answer. Tell me, this problem would be categorized under which segment, and what would be its precise most answer? I would like to have the input from each one of you. What would be the best most answer for this given problem? So the answer have started coming. The first answer have come from Manju. The Manju states the answer would be positive infinity. Seems to be very perfect. Still, I want one or two more number of inputs. Why deliberately I have taken this problem? Because many of the students think whenever we calculate the limit at its real pole, by default the limit does not exist. But this is not the case. Why? Try to understand this way. 1 upon x minus of 1 to the power of 2. If you would draw over the xy plane, here goes the vertical axis, here goes the horizontal axis. The horizontal axis has been marked as a x-axis, vertical axis has been marked as a y-axis. Plus infinity, positive infinity, yes, the answer have started coming. See what is happening over here. Obviously, if you will be focusing over this function, towards the numerator we had only and only constant, so at least from the numerator side I am safe. But at denominator side I have got x minus of 1 to the power of 2. So when the denominator becomes 0, definitely 1 is getting subtracted with an infinitely small value, would reach towards infinity. So may I know where the denominator would become almost 0? That would become almost 0 when the value of x is precisely equals to of roots of this polynomial, or I can say poles. May I know where the poles have been? Obviously x minus of 1 to the power of 2 has to get compared with 0, so the value of x we would be having obviously is going to be plus of 1. See what is happening over here, how the curve would look like. 1 upon of x minus of 1 to the power of 2. It would be very same as 1 upon x square. 1 upon x square was a rectangular hyperbola, and it was taking the reference of y-axis, but now it would take the reference of x is equals to of plus of 1 axis. Could you understand how it would be? Let me take the reference of x is equals to of plus of 1. Just a minute. How the curve would look like? The curve would look something like this. Why? Because one thing I had been quite sure, as the square has been attached along with the x minus of 1 to the power of 2, the value of denominator will never be negative. That's first thing. And as the denominator of the x minus of 1 to the power of 2 cannot be negative, and numerator had been the positive value, their ratio would always be a positive value. Whether it's a finite value, whether it's an infinite value. At x is equals to of 1, just try to understand in this way. At x is equals to of 1, the value would become 0. 1 upon 0 would become infinity. But I am going to take the reference of 1 minus, x is equals to of 1 minus, and similarly x is equals to of 1 plus. What does it mean by x is equals to of 1 minus? That means the x has been tending towards 1 from the left hand side, but could not reach exactly at 1 and has stopped around 0.999999. Once you feed the words as 0.99999, it becomes almost equals to of 0 minus. Obviously worth would be almost 0, but polarity would be negative. But as we have got the square over here, the 0 minus square would be made as 0 itself. Positive, negative, positive. So 1 upon 0 plus would make this as plus infinity, and the same case goes with this. Agreed what I am saying? So if we'll be focusing about the limit x tends to a or limit x tends to 1 divided by x minus of 1 to the power of 2, the result what we are supposed to have, obviously nobody should have any doubt as such, it would be plus of infinity, plus of infinity. Let me change this problem a bit. What I am going to do over here, I am going to frame a next problem almost had the same concept which we have been used in the last problem. See what this problem states. Again, the limit has to be buried at x is equals to a. A had been 1, but the problem has been changed to x minus 1 to the power of 3. X minus 1 to the power of 3. Again, there could be the two different possibilities. May I know what are they? The limit does not exist. If the limit does not exist, obviously you would not be able to conclude it's any perfect answer. And second, it could have the limit do exist, the value of left hand limit as well as right hand limit had been very same, and there you would be getting the precise most answer. Tell me what would be the best most answer for this given problem? What would be the best most answer for this given problem? Tell me what would be the best most answer for this given problem? I would expect this answer from each one of you. What would be the best most answer for this given problem? No, Renu sir is already there in Gate Academy. No, he has not left. Anyways, focus over this problem. Limit x tends to 1 divided by x minus 1 to the power of 3. 1 divided by x minus 1 to the power of 3. Tell me, limit do exist for this function at x is equals to 1 or does not exist? First, give me the answer in terms of yes or no. Limit does not exist. The first answer have come from primary. Obviously, the limit do not exist. Why? As the limit has to be checked around x is equals to 1, you would follow a path which would be keep coming towards 1 from the left hand side and similarly from the right hand side. From the left hand side, the path which we have taken which had been approaching towards 1 would be treated as f of 1 just before 1, which is nothing but the f of 1 minus, and here it goes f of 1 plus. Once you will be feeding x is equals to 1 of minus, keep in mind towards denominator you would be having 0 minus, and 1 upon 0 minus would convert this value as minus of infinity, and here it becomes plus of infinity, whether they are not same. Yes, as they have not been same, there is no doubt as such the limit would not exist, at least for this problem. Limit does not exist. Limit does not exist. In the same sequence, let me design the next problem, and they all have been a light problem, and you can expect this sort of problem straight away in Gate examination. Let's take the problem had been x divided by of x square. How the problem could have been designed? Let's take 2, 2, 2, 2. Okay, that has been 3 of x plus of 2, and the limit has to be taken at x tends to 5. At x tends to 5. Tell me what would be the best most answer for this given problem. See what happens. Whenever you have the division of the polynomials, specifically towards denominator side, you have got the polynomial. So the real polynomials or the real roots of the polynomials are the roots at which the function would cease its continuity as well as the existence of its limit. So may I know what are the different points at which the function would not exist its limit? You have to take its roots. How will I get this? I would be able to get this by comparing x square plus of 3x plus of 2 is equals to 0. May I know what are the values you will be getting? Obviously, after taking its middle term split, you could have been written this as x square plus of 2 of x plus of 2 is equals to 0. The x has been taken common, the worth has been left out is being this. So the roots are precisely going to be minus 1 and minus 2, But here the limit has been calculated around x is equal to 5, where the function had been a purely continuous in nature. Could you understand what I am saying? Because I have seen many of the time the student have by-hearted whenever they used to have a polynomial towards denominator side, that means the function's limit would not exist. It's not like that. When precisely the calculation has been made where the x has been tends to minus 1 or the minus 2, this function would not lead any of the fixed limit. But once you are doing the analysis anything apart from -1 and -2, definitely the limit would exist precisely. Limit would exist precisely. Tell me what would be the best most answer? We are just going to feed numerator as 5. Towards denominator side it's going to be 25. 5 3s are, that's going to be 15, and it's getting added with 2. It's getting added with 2. Till this point each and everything must be clear to all of us. Yes, 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 yes. The answer has started coming. So the numerator had been 5. Towards denominator side, once we'll add 25 with 15, the result would be 14. It's getting added with 2. The result would be 42. Why deliberately I have taken this problem? Because many of the students makes misconception that whenever they used to have a real polynomial or real poles, then the limit would not exist. No, the limit would not exist at -1 as well as -2. But here the calculation has been made at x is equal to 5. No doubt. No problem. No problem. Yes. In the same sequence, let me move forward. Let me bifurcate this. In the same sequence, let me take the next question. The question had been limit x tends to, let's take it had been 3 e to the power of x. Yeah, as far as the e to the power of x is being concerned, the e to the power of x has been a continuous function. What does that mean by the continuous function? A function is said to be a continuous at a certain test point, let's take at a, if the worth of f of a minus is very same as f of a plus is very same as f of a. One thing is quite sure, as the function had been continuous throughout the range of x, e to the power of 3 minus would be equals to of e to the power of 3 plus is equals to of e to the power of 3 itself. So what's going to be the best most answer for e to the power of x? It's precisely going to be e to the power of 3. E to the power of 3. Till this point probably nobody should have any doubt as such. Yes, nobody should have any doubt as such. Obviously, e to the power of 3. Yes, no? In the same sequence, let me move forward. Here goes the second question. I can design a problem like e to the power of 1 divided by of e to the power of -1 divided by of x, and here the limit has been reaching towards 0. Obviously from the left hand side as well as right hand side. Tell me what would be the best most answer for this given problem. There could be the two different possibilities. Limit does not exist. Secondly, the limit do exist. If the case goes into the existence of the limit, sir, please take mod function. Obviously, we'll take that also. Tell me what would be the best most answer for this given problem. Tell me limit x tends to 0, e to the power of -1 by x. Limit do exist for this function, limit does not exist for this function. If limit do exist, you also had to indicate its proper most answer. See, what had happened over here is almost same way which we have been dealing so far. See, what you are going to do, you are going to calculate or assess the worth of the function just before the test point and just after the test point. If you take the reference just before the test point, the x has to be fed as 0 minus. So here it becomes e to the power of minus, and minus goes out. Yes, just before 0, that could have been written as minus of 0.00001. But the minus and minus sign is going to go out. So it would be left out with e to the power of 1 divided by a very, very small positive value, which would lead this value as infinity. Similarly, once you'll take f of 0 plus, what's going to happen over here? The worth of the x had been a minutely small, but the polarity had been positive. So once you'll take the division of negative as well as positive, the result would be negative. There is no doubt. So here, the result what we are getting is simply going to be e to the power of minus infinity. We have discussed about the indeterminate form as well as we have discussed about the concept of 0 as well as infinity. Here we are getting the result as infinity, and here we are getting result as 0. Obviously, the function's limit would not exist. That has been the case. In the same scenario, let me do one thing. This problem has been interestingly changed to a bit different. Let's take it had been limit x tends to 0. E to the power of -1 divided by of mod of x. Again the same problem has been thrown towards you, whether the limit do exist or not. If the limit do exist, tell me what should be the precise most answer for this given problem. And Manju was keep asking, sir, why don't we take one or two number of problems based on the concept of the modular function. Obviously, deliberately I have involved a modular function along with the exponent function. Exponent function, I would like to have the input from each one of you. Tell me what would be the best most answer for this given problem. Even we will try to draw this curve over the 2D plane also. Tell me. So at least positive infinity. Manju stating positive infinity. Obviously, yes. See what is happening over here. Again, the analysis has to be done just before 0, that has been 0 minus, and just after 0, that has been 0 plus. Put together, 1 is getting divided with 0. Obviously, the power would be reaching towards infinity. But would it be positive or would it be negative? Would it be positive or would it be negative? See what I am going to say over here. You can do the analysis at x is equals to of 0 minus, x is equals to 0 plus. See what is happening. Once you will take the modular or absolute function would always change a negative value to the positive value. Once we do so, 0 minus would become a 0, minus of 1 divided by 0 would make it e to the power of minus infinity, e to the power of minus infinity would become 0. And the same case goes with this also, here also it becomes e to the power of minus infinity, which would be equals to 0. Yes, till this point each and everything must be clear to all of us. What I am saying, limit x has been tending towards 0, it has been e to the power of minus 1 divided by mod of x, where the x has had the two number of values, just before 0 which has been taken as 0 minus, just after the 0 which has been taken as 0 plus. So let me do one thing, let me draw this curve over the 2D grapher. The function had been e to the power of minus 1 divided by mod of x. So what I am going to do over here, let me draw this. Just a minute. So let me enter the session ID that has been 24838306. Let me present my mobile over here. So the curve which we had to draw over here had been e to the power of minus mod of x. So here at very beginning we had to take the exponent function. Just a minute. Yes, here goes the exponent function. Even you can take the exponent function is almost how much? 2.7. You can take even 2 also. Has been raised to minus 1 divided by of, just a minute, minus 1 divided by of mod of x. The minus sign is also there outside. See how the curve is looking like. You yourself would be able to analyze at x is equals to of 0. There has not been any sudden change. So one thing had been quite sure, that had been e to the power of minus 1 divided by mod of x, and precisely at x is equals to 0, either you go towards left hand side or right hand side, the worth of the function had been very same, and that had been 0. So one thing had been quite sure, that the limit do exist at this particular point. And one of the answer we have got it. Renu sir is there. Yes, Renu Raj sir is there, the great person, the very good friend of mine. Definitely he is there with our GATE Academy. Sir, when GATE Academy test series for GATE 2022 would be launched? Obviously we are going to make all of the announcement over the YouTube, so you would get all of the sort of informations in the YouTube channel itself. Otherwise you can use our front desk phone number and you can just contact them. You would be getting all of the informations there itself. Till this point each and everything is clear. So probably till this point each and everything must be clear to all of us. I would try to interact with all of the students who have been there live over the live chat. Any specific topic within the engineering mathematics where you find yourself very difficult, you can put it over the live chat, so we'll try to understand those concepts into the great detail. Otherwise we would end my session here itself. We would end my session here itself. Tell me. Okay, then this is all about today's lecture. In tomorrow's lecture, we would go ahead with the numerical problems based on the concept of the limit, which has appeared in different gate examinations. And tomorrow lecture would be very important lectures, because straight away we are going to pick the problems which have come in gate examinations, and we would try to analyze as well as solve those problems with the different varieties of the methods. Sir, please tell approximate date of launch, sir. Anyways, Gaurav, I think exactly I won't be able to communicate. It would be the best methodology. Just pick your phone, call to our customer care. Yes? Okay then. Bye-bye. Take care. Good night.